Welcome to this video involving quadratic functions and determining their maximums and minimums again. So one thing that we can be mindful of when trying to find the maximum point or the minimum point of a parabola is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If we write that as separate terms, we get x is equal to negative b all over 2a plus or minus the square root of b squared minus 4ac all over 2a. When doing that, notice that we are adding or subtracting something, the same thing, from negative b over 2a both times. So the negative b over 2a is like our symmetric point. It kind of determines our axis of symmetry. X equals negative b over 2a is the axis of symmetry. It also would be the x-coordinate of the maximum point or the x-coordinate of the minimum point. So if we want to quickly identify the maximum point or the minimum point of a parabola, we're going to look at the negative b over 2a. Let's go to our first example. In this case, we'll look at x is equal to negative 8 all over 2 times a, which is 1. Negative 8 over 2 would be a negative 4. Now that's not a solution to an equation. That's our vertex coordinate or our axis of symmetry. It's the x-coordinate of the maximum point or the minimum point of our parabola. Notice that this parabola is opening up because it's a positive number attached to the x squared. Since it's opening up, this will be a minimum point. So we will indicate that the minimum point has an x-coordinate of negative 4. And if we want to determine its y-coordinate, we can just plug in to the original function. Negative 4 squared plus 8 times a negative 4 plus 12 will be 16 minus 32 plus 12, which will be a negative 16 plus 12, which is a negative 4. So our first function has a minimum point at negative 4, comma, negative 4. That would be the same thing we would get if we completed the square to determine the vertex of that parabola. The vertex would have been at negative 4, comma, negative 4. So in our second example, we could do the same thing. The x-coordinate of the maximum or minimum point would be negative b all over 2 times a. Now be careful on this one. The a was a negative 1, which is x equals 3. So now when we look back at this function, it has a negative attached to the x squared, which means it's going to open down. Hence, this will be a maximum point at an x-coordinate of 3. If we want the y-coordinate, we could plug in x equals 3 to the original function. Be careful. Watch how we square with the negative involved. This is going to be a negative 9 plus 18 minus 5, which is going to be 9 minus 5, which is 4. So our maximum point for this parabola would be at 3, comma 4. And our final parabola, if we want to figure out its maximum or minimum point, the x-coordinate would be negative b all over 2a. In this case, negative 8 divided by 8 would be a negative 1. The parabola is opening up because it's a positive number attached to the x squared. So this graph will have a minimum at an x-coordinate of negative 1. And for the y-coordinate, we'll plug in negative 1 to the function and see what it evaluates to be. In this case, it'll be 4 minus 8 plus 3. Negative 4 plus 3 is a negative 1. So our minimum point would be at negative 1, comma, negative 1, which we could have also found through completing the square and identifying the vertex.